Good afternoon and welcome to the latest Cortex webinar. As you can see from your opening screen, hopefully this one's called Creating a Maintenance Strategy. My name is Ian Cramp. I'm a consultant to Cortex, and you can see again from the screen I'm a chartered engineer by profession. My specialism is electrical engineering, and I'm also a member of the British Institute of Facilities Managers. I've been in FM now for more years than I care to remember. The purpose of today is to talk about creating a maintenance strategy, and I hope you'll find this afternoon's session of interest to you. The things to bear in mind are that, first and foremost, we need to consider why maintenance is necessary. One of the big snags with maintenance is a lot of people think the only time you need to repair or fix anything is when it breaks. Unfortunately, that can be a wasted and futile expenditure, because you have to then contend with things breaking down and the excessive cost of putting them right again. It's a lot better to implement a good maintenance strategy, and we'll be talking about that. There are different types of maintenance as well, and I'd like to explore with you some of those. There are a variety of different types, some of which can be effective for certain purposes, others of which don't tend to be so practical and achievable. Having said that, the thing to bear in mind is that we really need to consider how effective our maintenance regime is. For most organisations, up to 50%, that's 50% of the money they spend on maintenance, is completely wasted. Unfortunately, they don't really know which 50% is wasted. I hope to be able to guide you and get you thinking about whether your maintenance is effective. How do you know? What can you do about it? How do you make sure that you're getting best value for money? And of course, the other thing is people seem to think you go through the process only the once. For any building, whether it's new, whether it's been established for a number of years, or whether it's coming towards the end of its useful life, you need to think about your maintenance strategy. Does it continue to work? And if not, what do you need to do to get it working again? Please bear in mind that most buildings have a life of about 80 to 100 years, longer if you live in a Victorian building. And the thing to bear in mind also is that during the life of that building, you'll probably need to completely replace and refurbish your building systems about 3 or 4 times. So it is important you fully understand the maintenance strategy. And by way of a recap at the end, I'm going to give you the top 10 issues, things that will, I hope, help guide you regarding your strategy for your maintenance, and give you a few pointers along the right path. So let's begin. What is maintenance? And the definition is here on this slide. Process of undertaking checks and repairs on assets. And please bear in mind, an asset is a piece of equipment that you own. And from a building point of view, windows might be assets, your carpet, your desks, the computer you're using, and lighting, small power. They might be grouped together as systems, but they're still assets. And usually, of course, the equipment itself needs maintenance. So why do we need to maintain? And there are a number of most important reasons why maintenance is necessary. And the first one is to make sure your building continues to operate reliably. Any building, be it large or small, grand or very minor, needs to keep the elements out. And you'd be surprised how many clients I see who don't think to look after the small things, like fixing broken tiles, check guttering, to make sure that the rainwater and the weather doesn't enter into our building. It's such a small cost item to do, and yet when done at the right time can make a big difference to the life of your building. Otherwise, once water gets into the building, you can be faced with ancillary problems, and these can include mould, rot, as well as water coming in and destroying the finishes. So to make sure our building continues to operate reliably and effectively, we need to carry out maintenance to it, both the building fabric and the building surfaces. The other reason, of course, and probably the most important one, is we need to maintain the asset value of our building. All buildings will decay. If you don't spend money at the right time in making them to a much better standard than perhaps they would otherwise deteriorate to, then you're going to run into big issues. Think of your car. What would happen if you bought a car, never put any oil in the engine, never had it serviced, never pumped up the tyres? It would last for only a short period of time. So consequently, maintenance is important not just to cars, but buildings as well. It would be good, wouldn't it, if we could identify when components are failing, or alternatively, when they start to become more unreliable. And for most people, this is something they don't really know how to do, and I'm going to be telling you about a couple of techniques to help you along that path. And of course, although I've left it till one of the later items, compliance with legislation is a really important need for maintenance. Most governments will accept that ideally everybody would maintain their buildings for the reasons I've discussed, but there is still a number of people out there who don't think any form of maintenance is necessary. That can lead to health and safety issues and could lead to injuries or fatalities. So as a result, most governments have implemented a system of maintenance regimes which are backed up by law. So if, say, you have a lift, that lift requires a maintenance regime and inspection. And of course the onus is on you to prove that you've done so. Then in that way, we hope there will cease to be any injuries or fatalities, certainly in those buildings. We also want to try and maximise the life cycle cost of each element of the building. And if you can bear with me, please, I'm going to be talking about that in a minute. But from a cost versus payback point of view, it's really a most important consideration. The other thing that so many people fall foul of if they rent a building rather than not own it is that at the end of the lease they think they can walk away from the building and leave it. Now unfortunately, of course, the landlord hasn't got the same point of view, and they will usually insist as part of the lease that the tenant is responsible for the cost of making good defects up to an acceptable standard comparable to when the tenant moved in. So consequently, even if you don't care about the people in your building and don't want to spend any money whilst you're there, you still have to incur this cost. So, and it's an important argument to do something about it whilst you can get the benefits of, say, redecoration or other maintenance specified in the lease agreement. Let's think a little bit about what a building needs to do. Within the building, apart from keeping out the weather, we need to consider the fact that users of that building want to undertake the duties which are necessary as part of the mainstream use of that building. So if you're a bank, people in there want to undertake banking related activities. And obviously we want people to be able to do this not just by day, but at night. So we need lighting, which has to work when people want to work there. Similarly, of course, we need heating if they want to work there in winter. Air conditioning perhaps if they want to work in summer. And all these services need to work 24/7 or at such times as the building occupants require them. If they don't work well, you can be led to a situation whereby the building won't be productive, and it could lead to you having to move the occupants of that building to another location. And I've known of some clients who've had to invoke the disaster recovery plans in order to cope with this situation. Far better again if you can make sure that your maintenance regime is of a good standard, because this is going to be the best way of minimising disruption and the consequences to the business. Obviously you could turn around and adopt the opposite view and say, we will spend whatever money it takes on looking after our building. Apart from wasting a lot of money doing that, unfortunately you will incur a significant running cost, and what this will mean, of course, is that cost will come out of the profits of your business. It could make you non-cost effective compared to other businesses who are your competitors. So not a good idea. We don't want to spend nothing on our buildings, but at the same time, we don't want to provide the best service in the world for the building services. Somewhere between the two is the best standard. And from a health and safety point of view, supposing we don't spend money on our buildings, we don't look after them properly, we don't test them, we could be faced with a situation where we get breaches of legislation, and this could lead to prosecution. The effects of that on your business could be dire. and you could find that you're faced with a situation where the building may have to close, or your reputation could be considerably harmed, as well as, of course, of the impact of the injury on people who work in your building. So you can see there a number of reasons why we need to think about maintenance. And before we go much further, we need to ask ourselves a question: why do things fail? A couple of clues on the right, the picture. But the thing to bear in mind is that building systems, and their assets as well, may fail for a number of reasons. First of these is design defects. This is where a building system was designed to standards not fit for where it's being used. Supposing you had a piece of electrical equipment that worked very well and was designed to work in the Middle East or the tropical parts of the world, and then you took it to the North Pole. It might be that it didn't work at all there because the designers never intended it to work under those environmental conditions. And equally, we have all from time to time bought equipment that perhaps doesn't do what we wanted it to do. Manufacturing defects are somewhat different, where with manufacturing defects, the design works okay, but unfortunately, when it's produced, you might find that there are faults and defects, and consequently, of course, we need to be aware of those as part of our maintenance strategy. And of course, we can also see from the two pictures on this slide that poor or no maintenance is a bad idea. We do accept that things will go rusty. If they're not looked after and given attention, we're going to get inherent problems. And of course, that will lead to poor operation and failure. We accept, of course, that with certain components, in fact, most of us drive a car that's subject to wear and tear. The tyres on a car, for example, will wear out, however carefully you drive. It's just as if you drive carefully, they'll last longer than if you race around the corner with your tyres. So consequently, of course, we do accept that even with the best of systems, there will come a time in the future when they cease to work properly. And ideally, from a building maintenance strategy, we want to try and identify that time and replace or repair before that stage occurs. Similarly, of course, length of use is an important issue. The longer we use something, we accept that it will last less, it'll be less useful and will wear out. Equally, if we abuse or maltreat a piece of equipment, an asset or a system, then again it's not going to last as long or be as reliable as if we take reasonable care of it. We know from our own experience that if we get a problem with a piece of equipment, it's more likely to occur when the equipment's brand new, and hopefully the warranty issued by the manufacturers of that equipment will cover its replacement if there's a defect when you take it out of the box, or maybe in the warranty period. Or alternatively, as the equipment ages, you get to a situation where you can find that, again, it becomes unreliable and we need to give it attention and repair or replace it. And really, our maintenance strategy should pick up both ends of this situation. Best way of expressing this is with something called the bathtub curve that some of you may have come across. The bathtub curve, as you can see on the slide, is this blue curve here, and it has three different parts to it. The first part is the failures which are due to wear out. And if you plot failure rate, so this is very high at this top end and very low at the bottom end, you can see that when equipment is new, it generally speaking doesn't fail very much. Then, of course, as we use it more and more, the reliability starts to decrease until the time just before it fails, whereby it's fairly high on the failure rate graph. Conversely, we can get a situation, as I said before, where you buy a new piece of equipment, you take it out of the box and it doesn't work because it's not been designed properly or manufactured properly or transported properly or installed or commissioned properly. And hopefully infant mortality failures or early failures will occur when the equipment's new, and over a period of time these should fall. But please bear in mind, of course, as I mentioned earlier, you should be able to get those replaced by the manufacturer, providing it's within the warranty period. And then as we go further on in time, we get to a stage whereby the failure rate drops off quite considerably. There will always be failures that occur for a wide variety of random reasons, and the green line indicates those. However, if you summate the three graphs, so the yellow graph for wear-outs, the green graph for constant failures, and the red rate for early infant mortality rates, the curve you get is in the shape of a bathtub. Our objectives with a good maintenance strategy is to identify and repair equipment between the time it's brand new and it's got through the warranty period. Then hopefully encourage, nurture it to have as long a period as possible when the failure rate is less, and then as it approaches the end of its working life and the failure rate starts to increase, we identify that and repair or replace it in good time before we get a premature failure. So let's look now at operation and maintenance. The problem with maintenance, it isn't cheap. You need technicians. And obviously, again, you can waste money if you don't spend that money wisely by maintaining your equipment to the correct standards. I know of most businesses who will in fact spend their budget very thinly over everything. And that's a bad form of maintenance, because what's happening is the critical items in your business don't get enough money spent on maintenance. The non-critical items get too much money spent on maintenance. And a good example of people who cost manage effectively their budgets for maintenance are the hotels. If you go into a hotel reception, you find that all the lighting's working, the carpet's clean, no sign of dust or dirt anywhere, and the receptionists are kind, courteous and polite to you. Because if there were issues in reception, you might well turn around and think, I'm not going to check in because my room could be as bad as well. However, hotels don't necessarily use those same standards back of house, and who knows what conditions the accommodation could be in that we don't see as customers. So hotels manage their maintenance money wisely. They focus on what's best for the business and will influence in a positive way the customers coming into their buildings. So our maintenance strategy should reflect our business needs. Obviously, from an FM point of view, we need to support the business in its activities, and we need to think about several ways in which we can do that. Once we've identified equipment that needs maintenance, we can then adopt a planned maintenance regime. And as you can see, this is a regime that gets undertaken at a fixed time. So, for example, there might be a visit twice a year, once a week, every 5 years. Generally speaking, these events are calendar driven, and they're popular both with clients and contractors because the biggest cost to a contractor is getting the engineer to site in the first place. You know what congestion's like these days, and obviously somebody has to drive the vehicle to get to your site to do one job. If while they're on that site they can do other jobs on the same visit, the cost reduces, the incremental cost reduces, and the other benefit from the client's point of view, apart from reduced cost, is that it will also make life easier to monitor. You don't need any special experience in maintenance engineering to control a maintenance regime when it's planned maintenance. All you need is the ability to use a calendar, and I think we've all got that. And the big thing to bear in mind, though, of course, planned maintenance sounds attractive, and for most people they're familiar with it, but unfortunately it's possible to over-maintain or under-maintain, and this is where a lot of money can be wasted on needless maintenance. The next type of business of maintenance, which is really the way we should all be going, it's now best practice, is business critical maintenance. This is where we look and analyse before coming up with a maintenance regime at those assets or systems which are key to the business operation, and the failure of which will result in cash flow not coming in. So, for example, if you operate a supermarket or a chain of supermarkets, then you'll find the computer system is most important, because if the computer system stops working, then people can't pay you for the goods at the checkouts. So consequently, you have to turn your customers away. So the general rule with business critical maintenance is that you spend it on the maintenance of the key factors and make sure they're maintained to a good standard, and you leave the rest so that if you do have enough money at the end of the year, you can look after the non-essential equipment, but you'll always be safeguarding those key drivers that will ensure that your equipment is properly looked after. The other type of maintenance is conditional maintenance, and this is where you only undertake maintenance when a certain condition has been met. The example here of power doors, it's very easy to put a counter on doors and you can carry out maintenance after a certain number of operations. That's conditional maintenance. Unfortunately, you can't do that readily on moving parts and equipment like pumps and motors and fans, and you need to undertake vibration analysis, which can be a costly exercise, but there are some buildings, like some tower blocks in the city, where the building was designed in such a way that it's unable, you can't get new plant and equipment up on the roof without flying it in by helicopter, because the lift shafts perhaps haven't been made big enough to allow new plant to be lifted up and down to the roof. So in those cases, conditional maintenance is the only thing you can do, because you don't want to discover today that your equipment has failed and you can't get a new piece of equipment flown into the roof of the building for another 3 months perhaps. The form of maintenance I wouldn't recommend to you is reactive or breakdown maintenance. This is when we only take action when something fails. The big snag with that, of course, it is a firefighting approach. It will cost you a lot of money needlessly, and the big problem with it, of course, is that not only does the equipment fail, and that could seriously affect your business, but you might have to invoke contingency plans, and the failure of that equipment could have an impact on other systems, parts of your building. So costs could be extremely high. And I know the temptation is to turn around and say we don't have money in our budget for maintenance, but think of the impact upon the asset value of your business and the operation and reliability of your business, and hopefully you'll realise it is a waste of money. So costs are higher. We need to consider effects of disruption, which could be significant to a building, and damage to other systems and the building itself. Before going any further, I'd like to mention the concept of life cycle costing. Some of you may have come across this already. If you have, please bear with me. Life cycle costing is determined as the cost to own and operate an asset throughout the life of the building. And let's assume, for the sake of this simple example, that you've got a light bulb in your building, one of those things. They're terribly inefficient. About 95% of the electrical energy that goes into them is given off as heat and only 5% as light. And the life of them is fairly poor, about 1,000 hours. And let's say if it was in your office, it would be about a year of operation. And let's assume it costs £1. Now, if your lease covers you for 10 years and you've got one lamp, then if the lamps are £1 each and you need to change one a year, you're going to need 10 lamp changes. So the asset cost is going to be 10 lamps to £1 each, which is £10. The cost to maintain and refix the lamp, though, if it's in the office, depends on how much you pay for a maintenance visit. And let's assume that's going to be £10. And then consequently, for 10 lamp changes, you're going to have £10 each, which is £100. So the total cost of assets and the maintenance required on them is £110. Now, please bear in mind, for true life cost cycle costing, we need to think about where the money's coming from to pay for those assets and the replacement of them, the energy use, which I haven't spoken about on this slide, and also the disposal costs. Do you think that we will always be allowed to throw the old lamps away into landfill? So the cost of that could increase. As a result, many of us have gone away from those lamps to this sort, and they're called compact source fluorescent lights, and let's assume, because they're fluorescent, they last about 10,000 hours or 10 years. Now, the cost of them maybe is going to be more expensive, although of course the cost has come down, but let's assume they cost £10 each. You'll see why in a minute. If we have a 10-year life of the building lease, then that lamp will need changing only once. So the cost of the change of the lamp is £10, and if you remember from the previous slide, that's the same as 10 of the other lamps. But of course, and this is the big difference, the labour cost is only for one lamp change at £10, which is £10. So the total cost is £10 for the lamp, £10 to replace it, which is £20, which is the best value for money. And that's without looking at the funding, energy use and disposal costs. So for true life cycle costing, we should look more than just looking at the cheapest. And the same argument also works for for using systems, equipment like generators, lifts, anything you use. The cheapest isn't always the best. We should be looking at life cycle costing. I mentioned earlier business critical maintenance, and I'd just like to recap on that. We do waste money on our maintenance, and we really need to focus our strategy for business critical maintenance towards those systems and assets that could stop the cash flow from coming in. And you might say, okay, if we have a pump or a motor that's important, let's have a spare one. But that can give serious problems, as you'll see in a minute. We need to make sure our maintenance regimes are robust. And generally speaking, the moment we lose an asset because it's broken, we want the other one in place now. It's no good waiting for 5-6 hours or a day for the new one to arrive, always assuming it's in your stores. We must also bear in mind, of course, that some of our assets aren't used often. It might only be once a year we use them, but at the same time, they've got to be operational when we need them, and they could well be business critical as well. Here's a typical example of a pump set. You'll find most of you, if you've got a heating system in your building, will have not just one pump, because the whole building goes cold if that pump backs up. You'll usually have 2 pumps. And usually there's a control system so that if one pump fails, it will swap over to the other pump. How do we know, though, that the second pump will function if the first one fails? If we don't test it from time to time, it might well seize up. So consequently, we should swap over from the running pump to the standby pump at intervals. But please don't fall into the trap of making sure that each pump runs for the same amount of time. Say, don't swap them over weekly, because what will happen is if one pump fails eventually, because it's at the far end of its life cycle its bathtub curve, then you'll find the other pump is in a similar position and could become unreliable as well. The best thing to do is run one pump for maybe 2 or 3 times as long as the other one. So if that pump fails, the other one is still fairly new and will cope with the load. The other thing that you should include in your business critical maintenance is the statutory maintenance of your building, because again, that is critical to the operation of your building. I'd also like to discuss the other reason for failure, single points of failure. These are items of equipment which, if they fail, and they might be very low cost items, can cause serious impact upon your business. And as I mentioned before, the most common example is a single pump, which if it stops, and it might be protected by a fuse. I'm going to show an example where that happened in a minute. You could get a situation where your building heating is packed up and consequently you've got to close your building. And ideally, as I said on the BCM slide just now, the best fix is to have an automatic standby. And if you can't do this, then you need to check regularly to make sure that everything's functioning okay till the problem gets fixed. I was approached by a client to help them following a problem they had in their building. This client, a large insurance company, decided they needed to store paperwork in their basement. Now I think you know what's going to happen, but the biggest risk of storing equipment in the basement, which they determined, was the fact of flooding. So consequently, they decided that in the basement they would put plinths made of concrete, onto which they would put the racking, so that if the basement flooded, then the documents would be safe from getting wet. And these were valuable documents like leases and that sort of thing, so they couldn't copy them and store them somewhere else. They needed the originals. They knew about the problems of water entering, and they decided they would have a pit and they'd have a pump in the pit so that if there was water, the pump would pump the water out. Unfortunately, one Sunday evening, there was a major flood caused by a burst water main outside. Water entered the basement and the pump tried to start, but it was protected by a little fuse that went pop, and consequently it didn't operate. And when they came into the building the following day, they discovered that the building was full of water. The cost of taking out and freezing and then carefully preserving the documentation that had been damaged by water was £750,000. So a high impact. And they said to me, what could they do in order to minimise that impact from occurring? Looking at the system, you can see what the major point of failure is. The single point of failure is everything to do with that pump. So the best thing to do is have a second pump in place, ideally fed from a different electrical supply to the first one, so that you're not having a commonality of failure. And even better, of course, is to have sensors, so if there's any water at all in the basement, you raise the alarm, and once it starts to rise, you have high alarms as well. That way you can call people in or get them in quicker, rather than wait till the following morning when the damage has been done. So that's one way in which single points of failure should be determined beforehand, and of course to do that, you've got to work out what you've got in your building. And working out what you've got is a really important thing. So many people can only see what they can view. They don't realise above the ceiling or in the floor there's equipment which nobody knows about, and which, if it packs up, could seriously affect the operation of your building. Things like drains, pumps, air conditioning units. So the first thing to do is to set up for every building an asset register. This has the details of the plant and equipment on it, and quite often these days it's put onto a database or computer-aided facilities management system. The information comes, generally speaking, by using people who did the original design or who've got a great deal of experience in maintaining buildings, and this is an area we help a lot of clients with when they get problems. We have to go through on a system-by-system basis, interpret the drawings, carry out site surveys and checks in order to make sure we know what's up in the building. Once we know what we've got, we can carry out the maintenance regime for it and decide what frequency we're going to carry out for that maintenance, and whether we go for planned maintenance, condition maintenance, business critical maintenance, single points of failure, all the things we've spoken about so far. The goal is to make sure we get cost-effective maintenance which will give reliability to the building and its occupants. To do this isn't a cheap activity, and please bear in mind, as I said right at the start, as buildings age, the maintenance requirements do need to be changed and upgraded and updated to reflect the changes within the building and its systems. Before getting a contractor to deliver the maintenance, you need to consider a number of things. Do you have details of all your assets? I've come across some clients who just take contractors on a walkabout of the building with no drawings. And most contractors are extremely good, but they don't have X-ray vision. And unless you tell them about things, they won't be able to allow for the maintenance. Have you defined what maintenance regimes you want for each of your systems? Highly important. Will the contractor know what they've got to do and how to do it? Because without that, they're going to be stuck. They will do the best they can, but it might not meet the needs of your business and the operations within it. Who's going to keep records? Where? When? Please bear in mind, you might change the contractors that you use over the life of the building. You don't want them to go off with your information, because that's the whole history about how your building and its systems have been performing. And as I said before, you need to update things, and remember that as the assets are near the end of their useful life on the bathtub curve, you might have to do more frequent inspections or replacements. The different ways in which we can achieve maintenance specifications. This is one, which is the PATH system, which has been used since 2008, very widely accepted, and you can see from this particular slide, we start off first and foremost with our strategy, what our policy is for managing our assets, and this in turn gives us what our objectives are, and also, of course, how we deal with our contingency planning. Are we willing to accept downtime and failure? If we are, we can reduce the standards of our maintenance. From this, we can decide what we're going to do in terms of our maintenance, implement the plans, and check to make sure that everything's going okay. Of course, like any other good system, it's a closed loop system, so we end up back where we started, because we should always be assessing whether we're investing our money wisely in our maintenance regime. If we're over-maintaining, reduce the cost. if we're under-maintaining, increase the cost. PAS 55 is in fact a British Standards Institution and Institute of Asset Management specification. Very good system. Amongst the many things it will do for you, it's got a 28-point checklist which gives you good practice in life cycle planning, cost optimization, joined up thinking, and so on. It's fairly popular, particularly on large estates, and it will work in any sectors and for all types of assets. And it's fairly user-friendly as well. You also get examples of good practice, because part of maintenance is doing the work, part of it is inspecting, checking. Just walking around a plant room, you can often hear, if you're familiar with that plant room, whether things are going well or things aren't. Another scheme that's about to be introduced is ISO 55000, and basically that works in a similar way to ISO 9000, whereas it's a system for overviewing your asset management and coming up with the requirements for an integrated management system for those assets. And this also gives guidance for system implementation. BIFM have also been involved in some other standards, and these include 15221 Part 3, which is quality in FM, and you might say that's nothing to do with maintenance, but it is. The taxonomy of facilities management is in Part 4, and facilities management processes is in Part 5. They've also included space measurement in Part 6. So say, watch out for ISO 55000. It is pan-European, so that might give you benefits and advantages if you're in an organisation that operates in a number of countries. You might have the best specification in the world. You might have the best standards in the world. How do you get somebody to deliver to those standards? Choosing your contractor is a really important issue because ultimately you're relying on technical people to come to your site to carry out work. And to do this, most of us use a specification. What form of tender are you going to use? If you're with an organisation that produces power stations, then you might have a good procurement tender that will cover purchasing power stations. However, is it suitable for maintenance? So you might need to make a number of modifications. Please bear in mind as well that no two buildings in this world are the same. They might be constructed physically similar, but certainly the way in which they're used will determine how equipment wears in them. You need to be mindful of that. Your contractor, of course, doesn't really know how you use your buildings, so it's important you give them details as to how your equipment functions. And again, who are you going to choose? The cheapest? The most expensive? People with the most experience? There are a large number of people out there who say they can help you do your job, and it's important really that you come up with a specification and select a suitable contractor that will help you in the best way possible. It's a lot easier, in my experience, to get contractors to work on a 9-to-5 basis, but quite often the only time we know how well a contractor works is out of hours when we have a critical emergency and the stores are closed and that sort of thing. And that's really when you know how good or bad your contractors are. So think very carefully, not just about the ordinary maintenance, but the backup and support that you need in the event of a problem. Do you want them to act in your best interests? They certainly should do, and I think most contractors, providing they know where you're coming from, will try and achieve the standards that will help you best. Unfortunately, if you don't tell them what you do, what's critical to you and your business, then don't be surprised if they take their own view, which they believe will be best for most of their customers, but might not be the best suited for you. But how quickly will they respond in emergency? And can you work with them? Reliance on your contractor is important. Bear in mind they're safeguarding you not only from system maloperation or non-functioning, but also they can cover other important issues for you like risk, like health or safety issues. And you're very dependent on them because it's very rare for most clients, in my experience, to want to be able to or to actually undertake every activity themselves. Most of them will contract out at least a specialist maintenance management control because, of course, they don't really have the expertise or staff in those areas. Ultimately, of course, with a contractor, who's spending a significant part of our maintenance budget, we want to make sure that we're not going to be swindled and we're going to get good value from them. Please be reassured the vast majority of contractors I come across are extremely good, but you do need to go through the process of selecting the right ones for you. They all offer slightly different services, some of which will be better for your needs than others. And what can you do to help your contractor? I've said before many times that buildings are totally different. If your contractor doesn't know and understand that you have key activities, say once every quarter when the quarterly results come in and your accountants are spending the next week or two to get those published to the stock exchange, they clearly don't want any disruptions during those times. So it's vital to make sure that you're covering those activities. You need to explain to your contractor when assets can't be accessed, but please bear in mind the old trap, especially with IT systems, you can never carry out access to computer rooms and the maintenance of them. It's vital that you do this because even 24/7 systems will need maintenance at some stage, and it's always better to have a planned maintenance outage rather than have the system collapse when you need it most, which is usually at the busiest time of your trading. The other thing which is important is to minimise the work that's undertaken out of hours. By doing this, you're then in a stage whereby you're getting the work undertaken more efficiently and effectively. And with the best one in the world, we don't like working out of hours, nights and weekends. Given the choice, we'll all work far more effectively during daytime. As I mentioned earlier, if the system is business critical or is important, really important to you, consider a duplicate system. Don't rely on spares because, like the example I gave you earlier on, if your plant room is flooded, then you forget it. You don't just want an ordinary plumber to replace the pump. You want somebody who's got a sub-aqua qualification as well, and there aren't too many plumbers with that in the southeast. Please make sure your contractor is aware of all health and safety aspects and operational issues. They don't know where the asbestos is in your building. There might be locations where there are hazards or issues or things change from day to day, which you know about, but they don't. What they fully understand is the systems, the boilers, the chillers, and they understand those as equipment, but obviously they don't know your system and how it works within your building. The other thing I think is important is most contractors are a good source of reference in order to help us to provide information to assist with future planning. Has the engineer done the work? Ask them to show you what they've done. Ask to see any parts which have been replaced. Make sure they leave the work area clean and tidy. See if they found out any other problems. Ask for keys, etc. to be returned. Get them off the site and make sure you know when they've left. That could help from an invoicing point of view. Please as well, make sure the work they've done is updated on your CAFM system. Again, so many clients don't bother to do this. Why invest all that money in maintenance if you don't have clear records as to what's happened? Which brings me briefly to auditing. How can you make sure everything's working? Are you spending too much time on your maintenance? Do you get too many complaints? Are your energy bills too high? Does the help desk give you good information or bad information? Do you comply with legislation? Auditing can solve all these issues and more. And this is the wheel of continuous improvement. I like to use it because wherever you start from an auditing point of view, you get back to where you started. So you might look at the data collection phase and think, where are we at the moment? What do we know? Well, this room's a bit too hot because the air conditioning doesn't work very well. What are we trying to achieve? Cool the room. Is this happening? No. Action plan. How can this be improved? And are there alternatives? And then once we decide what to go for, we can implement the actions, check to see the results are achieved, and then are we achieving what we look for? Yes, indeed. Everybody's happy. Complaints are dropped. We can move on to the next issue. That's auditing. And it might be that you don't have the skills, the time for undertaking auditing, which involves information gathering, analysis, Benchmarking can be a most important aspect, and at Quartex, we do help our clients a lot by good, effective benchmarking to make sure the money you spend is a wise investment, comparable with the risks, and making sure that the standards are as they should be. And we regularly review what's being done and come up with answers for you. So collecting information can involve having a plan, what you need to use, who needs to be involved, and the timing process of it. And of course, a desk study is an important part, which involves collecting information. And please remember, your information is so valuable. And where do you keep it? Is it secure? And is it accessible? Have you got a good system that will enable you to obtain that information and retrieve it whenever you need to? You might be involved with your stakeholders because ultimately they're the ones who determine what standards you should be having, not necessarily your customers, but your line managers, directorate of your organisation, senior executives. Establish from them what standards are required and make sure that you're able to achieve those, and if not, you understand why and what the issues are. And there's no substitute for walking around the building, seeing what's happening with your own eyes and ears, and that will often be the best way of providing you with the way forward. At Quartex, we believe very much in everything to do with facilities management and real estate. We've helped so many organisations to achieve what they're looking for, and we focus very much on enabling them to do so. It's not all about the best of systems at the most expensive. It's very much about matching maintenance strategy to your needs and business requirements. If we can reflect from an FM support point of view and support your business strategy, then that's the most important thing to do. You can trust us. We believe very much in being honest with you. We'll tell you if there are issues. We can use our extensive experience to provide you with benchmarking and other advice. And we also work internationally, and we're well known internationally. So, to recap, top 10 issues. What's your business strategy, especially for maintenance? How will that affect your building and the loss of asset value, backlog maintenance, if you don't do anything? The last thing you want to do is incur significant costs year upon year. Don't focus just on fixing problems. Think very much from a strategic point of view. Your single points of failure can be the big showstoppers. Focus on them. Establish what's important to your customers, which might be a little bit different to your staff, and make sure you can deliver that to the standards that suit your business strategy. Keep your asset register up to date, because unless you do that, your maintenance budget won't reflect what you're actually having to do. Audit, audit, and audit. Please remember that as time marches on, your building is living, it will deteriorate. So review your specifications, update them, if necessary retender, but always make sure you're getting the best people to do what you want to and that they're delivering it for you. And present the essential elements to explain and make decisions. Clearly your board don't necessarily understand the detail that you might do, but it's important you explain to them what is necessary, why it's necessary, and the benefits that could be achieved in your business. And finally, and perhaps the most important, save till last, can you afford to let equipment fail? Because that could mean your business will die too. Well, I hope you found this session interesting and useful. Obviously, if you do have questions, please use the Get in Touch box on the Quartex website, and we'll get questions and respond to each of you as necessary. And I'd just like to remind you that our next webinar is on managing a facilities management procurement process. That will take place on the 24th of September 2013 at 4:30 British Summer Time. And again, we'll last for around about 45 minutes. Right, well, thank you very much indeed for your attention, and we look forward to seeing you at one of our next webinars.